Hi, I am Syed on Maths Online. Today's topic is Gauss Divergence Theorem. So let me first give you the statement for the Gauss Divergence Theorem. If V is, so let me define the statement. If V is the volume bounded by a surface S and vector F is a continuously differentiable function. Continuously differentiable function. So this vector f is a continuously differentiable function and it is a vector function. So in that case you can define triple integral. Triple integral represents the volume. So we have divergence of vector f into dv. This will be equals to double integral over s. It is vector f dot n cap into ds. This n cap is a positive unit vector which is drawn outward the normal to S. So that's a statement we have. Let us take few problems based on this Gauss divergence theorem. We even call Gauss divergence theorem as only divergence theorem also. The question is, if vector f is equals to 2x square minus 3z times of I minus 2xy into j minus 4x into k, evaluate triple integral over v, divergence of vector f into dv, where v is a region bounded by the planes x is equals to 0, y is equals to 0, z is equals to 0, and 2x plus 2y plus z is equals to 4. So let us first find out the divergence of vector f. So this del represents, it is dou by dou x of I plus dou by dou y of j plus dou by dou z of k. Then dot product of vector f. So vector f is given in the question, which is 2x square minus 3z times of I minus 2xy into j minus 4x into k. So once again, here, because it is a dot product, you have to take I dot I as 1, so it becomes dou by dou x of 2x square minus of 3z. Then take j dot j value, you will be getting dou by dou y of, here it is minus of 2xy, then plus dou by dou z of, what you have, it is minus of 4x, which is equals to, now if you try to differentiate with respect to x over here, you'll be getting 4x. Here 3z is a constant, its derivative will be 0. Here you have minus of 2x as a constant, derivative of y with respect to y will be 1. Here minus 4x is a constant with respect to z, its derivative will be 0. So you have 4x here and minus of 2x. So 4x minus 2x will be 2x. So we got divergence of vector f. Now because it is a triple integral over here, we need to get limits for the values of x, y and z. So let us try to get the limits over there. So for that, try to observe the values that are given over here. X is 0, y is 0, z is 0, and this equation is given. 2x plus 2y plus z is equals to 4. So let us take z as 0 over here. So when the value of z is 0, what will happen to this equation? This 2x plus 2y plus z is equals to 4. So if you put z as 0 here, I will be getting 2x plus 2y, z is 0 over here, is equals to 4. So you have 2x plus 2y is equals to 4. So can I divide this by 2 throughout, or you can take 2 common. So if I divide by 2, we'll be getting x over here. If I divide by 2, we'll be getting y over here. If I divide by 2, so 2 times of 2. So we'll be getting x plus y to be 2. So when z is 0, you'll be getting the value of x plus y to be 2. So suppose now if I take the value of y to be equals to 0. So when y is 0, what will be another value over here? So from here, can I get the value of y? Y will be equals to, send this x on the other side, will be getting 2 minus x. So the range for the value of y will be 0 and y is equals to 2 minus x. here the range for z is 0, and what will be one more value over here? One more value for z will be, you take this 2x and 2y on the other side, you'll be getting 4 minus of this 2x goes on this other side, becomes minus of 2x. This 2y goes on this side, will be getting minus of 2y. So the range for z will be z is equals to 0 and z is equals to 4 minus 2x minus 2y. To get y, I have put z as 0, I have got y to be 2 minus of x. So the range value for y will be 0 to y is equals to 2 minus of x. Again, if I put z to be 0 value and y to be 0 value, because I want to get the value of x, therefore I am taking z as 0, y as 0 in this plane. 2x plus 2y plus z is equals to 4. So if you put y as 0 and z as 0, there will be getting 2x, y is 0, z is 0. So you get 2x to be equals to how much? 4. X will be how much? 4 by 2. Therefore we'll be getting the value of x to be 2. So what will be the range for x value? So x range will be 0 to 2, because x is equals to 0 is already given in the question. One more value of x I have got, x is equals to 2. So now if I take triple integral divergence of vector f into dv will be equals to, so limit values for x is 0 to 2, limit values for y will be 0 to 2 minus of x, and limit values for z will be 0 to, its value is 4 minus 2x minus of 2y, into this divergence of vector f. You have got divergence of vector f, you have got its value to be equals to 2x. So this value is 2x. What does dv represents? The value of dv is nothing but dx, dy, dz. So now if you want to write down, because the inner limit value is with respect to z, alright, so first I will be writing with respect to z. Next you are having the limit values with respect to y, I will be writing y. Then you have x, I will be writing dx. So in place of dv I have just rearranged and written the values. So now it is integral x is equals to 0 to 2. You have integral y is equals to 0 to 2 minus of x. This 2x is a constant. You have to integrate with respect to z. Integral of dz will be z. Limit values for z is how much? Z is equals to 0 to 4 minus 2x minus, it is 4 minus 2x minus 2y. Integration of dz is z. Limit values for z will be 0 to 4 minus 2x minus of 2y. Then this dy and dx will remain as it is. Let us apply the limits over here. So this is integral x is equals to 0 to 2. This is integral y is equals to 0 to 2 minus of x. This is 2x as it is. Apply the upper limit value for z. It is 4 minus 2x minus of 2y. Minus lower limit value for z is 0. Times of what you have? Times of dy and dx you have. Further let us try to integrate it. The integral x is equals to 0 to 2, and this is integral y is equals to 0 to 2 minus of x. So just multiply this one. You'll be getting 4 times of 2, 8x, minus of 2 times of 2, 4x square, minus 2 times of 2 will be 4xy, into what you get? Into dy dx. Now let us try to integrate with respect to y. You are integrating with respect to y over here. 8x integral of dy will be y, minus of 4x square integral of dy will be y, minus 4x integration of y will be y square by 2, and the limit values for y will be y is equals to 0 to 2 minus of x times of dx. So here let us apply the limits for y over here, which is integral of x is equals to 0 to 2. You have 8x times of, upper limit value for y is 2 minus of x, lower limit value will be 0, minus of 4x square, upper limit value for y will be 2 minus of x, minus lower limit value will be 0. This is 2 1 times and 2 2 times. So minus of 2x as it is. Upper limit value for x will be 2 minus of x. So 2 minus of x whole square minus lower limit value will be 0 times of you have dx. Let us try to simplify this one, which is nothing but integral of x is equals to 0 to 2. So let us try to multiply this one. So 8 times of 2 will be 16x minus 8x into x will be 8x square minus of, again multiply, 4 times of 2 will be 8x square, then minus of minus will become plus 4x square into x will become x cube. Then over here it is minus of 2x as it is. Here because it is in the form of a minus b whole square, you can expand it. A square, 2 square will be 4 plus b square will be x square minus of 2 times of a into b. So 2 times of 2 will be 4. So 4x will be getting times of what you have, times of dx. So before we integrate, let's further simplify this one. It is 0 to 2. You can see over here this is minus 8x square will be minus 16x square. So let us try to write down it is 16x minus of 16x square plus 4 times of x cube. Now let us multiply this 2x inside. So we will be getting the value as 8x. Minus into plus will be minus 2 into x square will be x cube. Then minus of minus will become plus 4 times of 2 will be 8. X into x will be x square times of dx. Now we'll try to group the like terms over here. So like terms over here, it is 4x cube minus 2x cube will be 2x cube. Then over here 16x square and plus 8x square. So minus 16 plus 8 will be minus of 8x square. Then next term you have plus 16 minus of 8 will be plus 8x. Right? Those are the terms you have. Times of dx you have. Now let us try to integrate this one. It will be equals to 2 times of integral of x cube will be x power of 4 by 4. Limit values will be x is equals to 0 to 2 minus 8 times of x square integration will be x cube by 3. Limit values will be x is equals to 0 to 2 plus 8 times of integral of x will be x square by 2. Limit values will be x is equals to 0 to 2. We'll try to simplify this one. This is 2 1 times. This is 2 2 times. So here 2 1 times, 2 4 times. So 1 by 2 is a constant you can take outside, and upper limit value will be 2 power of 4, lower limit value will be 0. Here minus 8 by 3 is there. Upper limit value for x will be 2, so 2 cube. Lower limit value will be 0 plus 4 times of upper limit value for x will be 2, so 2 square. Lower limit value will be 0. So it is 2 power of 4 will be 16, so 16 by 2 minus it is 8 by 3 into 2 cube will be 8 plus 2 square will be 4, 4 times of 4 will be 16. So let us try to take the LCM and simplify this result. So LCM I can take it as 6 over here. So we can just multiply 16 times of 3, it is 48 minus of, you have to multiply 2 over here. It's 8 times of 8 is already 64. 64 has to be multiplied by 2. So you'll be getting 128 plus multiply the 16 times of 6. The 6 has to be multiplied. So 16 times of 6 has to be multiplied. You get 96. So let us try to simplify this one. You are having 96, 48. You have to add it. So if you add, you will be getting the value as 144. So from 144, subtract 128. So 14 minus of 8 will be 6. So 3 minus 2 will be 1. So we'll be getting 16 by 6. Or if you further cancel out, it is 2 3 times 2 8 times. So we'll be getting 8 by 3. Therefore the final solution for the divergence will be 8 by 3. So that will be the required solution. If vector f is equals to 2xy into I plus yz square j plus xz K, and S is the rectangular parallelepiped bounded by x is equals to 0, y is equals to 0, z is equals to 0, x is equals to 2, y is equals to 1, z is equals to 3. Find the flux across S. So what is this flux across the surface S? So the flux across the surface S is nothing but double integral over S vector f dot ds vector is equals to, it is double integral over the surface S vector f dot, and we know ds can be written as, ds vector can be written as n cap into ds. But we have a relationship for this surface S and the divergence by using the divergence theorem. So from the divergence theorem, we know that double integral over the surface S vector f dot n cap into ds is nothing but triple integral over the volume V. It is divergence of vector f into dv. So first let us find out the divergence of vector f. So we have divergence of vector f, that is nothing but del dot vector f. That will be nothing but, it is del value is dou by dou x of I plus dou by dou y of j plus dou by dou z of k. Dot product with vector f. Vector f is given in the question over here. So you can use that value. It is 2xy into I plus yz square into j plus xz into k. So you can take the dot product over here. I dot I will be 1, so we'll be getting dou by dou x of 2xy. Then j dot j will be 1, so we'll be getting dou by dou y of y z square. Then k dot k will be 1, we'll be getting dou by dou z of x z. So now if you are trying to differentiate with respect to x over here, you'll be getting 2y. If you want to differentiate with respect to y over here, you will just be getting z square. If you want to differentiate with respect to z, you will just be getting x. So we got a divergence of vector f. The range for x value is already given in the question. X is ranging from 0 to 2. Y is ranging from 0 to 1. Then z is ranging from 0 to 3. You can just see over here, x is ranging from 0 to 2, y is 0 to 1, z is given as 0 to 3. That is the boundaries for the rectangular parallelepiped. So if you want, you can just draw the rectangular parallelepiped, or you can just solve the problem without drawing it. So now if I try to use that in the divergence theorem over here, right, so therefore I can substitute this value back over here. So we get the left hand side as it is, vector f dot n cap into ds will be equals to integral of x is equals to 0 to 2. Triple integral is there. So second value will be y is equals to 0 to 1. Z value will be 0 to 3. And then what you have, vector f dot n cap into ds value. So what you have, divergence of vector f, we have already calculated the value of divergence of vector f to be equals to 2y plus z square plus x into dv. dv is already known, it is dx dy dz. Inner limit value is z, therefore I'll write dz. Here I'll write dy, then I'll write dx. So let us try to integrate this one. This integral x is equals to 0 to 2. Then you have integral y is equals to 0 to 1. Let us try to integrate with respect to z first. 2y as it is, you will get integral of dz will be z. Then z square is there, we will be getting integral as z cube by 3. Then you have x, integral of dz will be z. Your limit values will be z is equals to 0 to 3. You have, it is dy dx. Now it will be equals to integral of x is equals to 0 to 2. Then you have integral y is equals to 0 to 1. You need to apply the limits for z. So we'll be getting 2y. Upper limit value for z will be 3. Lower limit will be 0. Plus 1 by 3 times of upper limit value for z will be 3. So 3 cube. Lower limit value will be 0. Plus x times of upper limit value for z will be 3. Lower limit value will be 0. Times of what you have, it is dy dx. Let us further simplify this expression. So you have integral x is equals to 0 to 2. Then you have integral y is equals to 0 to 1. Let us try to multiply it. This upper limit value is 3. So 3 times of 2 will be 6. 6y you get. Here plus 3 cube will be 27. So 27 by 3 will be just 9. So 9 times will be 27. Then plus you have 3 times of x, 3x. Times of what you have, it is dy into dx. So now let us try to integrate this one. So it should be equals to, it is integral of x is equals to 0 to 2. We are integrating with respect to y. So 6y square by 2. 9 times of integral of dy will be y. 3x is a constant. Integration of dy will be y. Limit values for y will be y is equals to 0 to 1 into dx. So you can cancel out 2 1 times, 2 3 times, which will be equals to integral of x is equals to 0 to 2. It is 2, this is 3 times of upper limit value for y will be 1. 1 square will be 1, lower limit value will be 0. It is 9 times of upper limit value for y will be 1, lower limit value will be 0, plus 3x as it is. Upper limit value for y will be 1, lower limit value will be 0, times of what we have, times of dx. So let us try to simplify it. Integral x is equals to 0 to 2. Just multiply 3 times of 2. So just multiply it. This is 3 times of 1. It is 3. Over here you have 9. Here you have 3x into dx. Or you just add one more step. Just add it. 9 plus 3 will be 12 plus 3x times of what you have, times of dx. Now integrate with respect to x. 12 as it is. Integration of dx will be x plus 3 times of integral of x will be x square by 2. Limit values will be x is equals to 0 to 2. So let us try to simplify this one, which will be equals to, it is 12 times of upper limit value for x will be 2, lower limit value for x will be 0, plus you have 3 by 2, upper limit value for x will be 2, so 2 square, lower limit value will be 0. So 12 times of 2 will be 24 over here, plus you have over here 4, 4 times of 3 will be 12, 12 by you have 2, or if you just cancel out 2 1 times 2 6 times, you will get 24 plus 6 will be 30. So this will be nothing but double integral over the surface S vector f dot n cap into ds. So we have evaluated this surface integral using the Gauss Divergence Theorem. That's the required solution we have. So that's all I have for today. Thank you.